record this. Okay. Okay. So whenever we were actually creating the tuple, we were actually calling it as packing. And whenever we actually had a tuple like this, so fruits, and it had three elements. And whenever we had three variables like this, and we just assigned it to fruits, so what happened was to this green, apple was allocated, to this yellow, banana was allocated, and to this red, cherry was allocated, right? So this was nothing, but it was called as what? Unpack, right? Now, we will just continue from where we left off. So, again, whenever we have a Python tuple, so there is another type of unpacking that we can do, right? So suppose we have a tuple called as fruits and which has five elements. Okay. So very quickly, just let us write the elements. Okay. So I will first write Python. Okay. So interactive Python shell opened, right? And then we will write fruits is equal to, we will write a tuple. So round brackets, and we will have suppose apple, banana, cherry, strawberry, and raspberry. Okay. Suppose these are the five elements that we have uh, in the tuple called as fruits, right? Now, so in the previous example, we saw that we had three variables and three elements were allocated to these three variables. Okay. Now, suppose it may happen that we have less number of variables, but more number of elements in the tuple. Okay. So in that case, what we can do, let us understand. So if I write green, yellow, and red, and I assign these to fruits, you can see error is coming that too many values to unpack. Okay. So here we have three variables, but actually we have how many values? Five values. So too many values to unpack, right? Expected three. Okay. But actually we have five. So in that scenario, what we can do, let us understand. So we can write green, we can write yellow, and we can write something called as asterisk of red. So we are actually defining a pointer to the variable called as red, right? Now, what does this mean? It means that, and if I assign this to fruits, it means that the green will be allocated to apple, right? Yellow will be allocated to banana. And since this is a asterisk red, so asterisk red will be nothing but a pointer, right? Now, what's a pointer? Pointer means that we can create an array called as red, or we can create a list called as red. And in that list, we can actually store what? All the three remaining items. So, which means cherry we can store strawberry as well as we can store raspberry. Okay. So, let us see what happens. So, if I just allocate them to fruits and if I press enter, and now if I print green, you can see it is printing apple. If I print yellow, you can see it is printing banana. But if I print red, you will see that it is actually a list where all the remaining items or remaining elements of the tuple are being stored in the form of a list, right? Okay. The same thing we can do a bit differently. So in the next scenario, let us see that suppose instead of writing asterisk in front of red, let us say that we write green. Let us say we write asterisk of yellow, right? And then let us say we write red. Okay. And then let us we say that we assign it to fruits. Okay. Now let us see what happens. Okay. So in this scenario, what happens is green will be allocated to apple, right? This yellow should be a list, but this list should contain how many elements? We will find out. Okay. How we will find out? So after this pointer variable called as yellow, we are having only one variable, right? Called as red. So obviously this one variable will be, let us say, it will be allocated to the last element that is raspberry. Okay. So if I allocate red to raspberry and green to apple, all the other items, remaining items in between will be allocated to yellow as a list. Okay. So if I press enter and now if I print green, it will print apple. If I print red, it will print raspberry. But if I print yellow, you can see that it will print what? Banana, cherry, and strawberry. Okay, so if I print yellow, you can see that again it's a list where we will have three items: banana, cherry, and strawberry. Okay, I hope I'm clear with this idea. Okay, now, so again we can loop through tuples using a for loop. Okay, so again if I have a tuple called as fruits, so what I can do, I can write for x in fruits, right? And if I give four spaces and I print x, so what will happen? Every element will be printed in new lines. Okay, so you can see that every element of the tuple is being printed in new lines. Okay. Similarly, we can use the range function and the len function also to use the indexes, right? So if you remember, whenever we started with tuples, we said that actually we can just access the elements of a tuple using the index numbers, right? So again, we can use the same concept here as well. So what we can write? We can write for x in range. Now, if you remember the concept of range, whatever parameter we will pass in range. So suppose we pass 5, so which means x will iterate from 0 to 4, right? If I pass 3, which means 0 will iterate from 0 to 2. Okay. So in this range, what I can do, I can write len of fruits. So what is the len of fruits? It is 5. So obviously it means x will go from 0 till 4. Okay. So in this scenario, if I press enter, I give 4 spaces, and if I print fruits, since we can access indexes, so we'll use square brackets and we will write what x. Okay, so x will first, it will be 0, so it will print fruits 0, zeroth element. Then x will be 1, it will print the first element. Then it will go to 2, it will print the second element, and so on in new lines, obviously, right? So if I print this and if I press enter, you can see again it is printing the same. Okay, and since we are using indexes, so obviously we can also use while loops as well. So in the case of while loops, what's that? What we can do? So initially we have to initialize the iterator. So suppose I can initialize iterator as a 0, right? And I will write a while loop condition. Condition is what? While I is less than the len of what fruits. So while I is less than 5, what I will do? I will print fruits of what? 1, fruits of I, right? And after printing this thing, what I will do, I will write I plus equal to 1, right? So again, if I just press enter, you can see it will print it the same. Okay. So I hope I'm clear with till this, right? Now, now to join two or more tuples, we can use what? The plus operator, right? So again, if I have two tuples, like for example, if I have tuple 1 and let us say we have A, we have B, and suppose we have C, right? And suppose we have tuple 2 where we have 1 comma 2 comma 3 like this. Okay, and if I just write tuple of 1 plus tuple of 2, uh, okay, sorry, tuple 2 was actually should be wrong, should be wrong. So now if I write tuple 1 plus tuple 2, again you can see that both the tuples are actually added together and then printed out. Okay, also what we can do is we can use the star operator. Now what is this star operator? Let us understand. So suppose we have tuple 1 as A, B, and C. Now what I can do is I can write tuple 1 into 2. If I write tuple 1 into 2, let us see what happens. So again, there were one instances of A, B, and C. Now if I just multiply it by 2, so again you can see that there will be two instances of all the elements, that is A, B, and C. So two instances of A, two instances of B, as well as two instances of C. Okay, so again we can use the asterisk operator as well to multiply elements of a tuple. Okay, now these are some of the bonus methods: count and index. So again, if I want to count the number of A's in tuple 1, so what I will do, I will write tuple 1 dot count, and suppose let us write A. So obviously it will be equal to 2. What happened? Okay, sorry. I did not save it, right? So if I just print tuple1, it's same thing. So if I just write tuple1 is equal to tuple1 into 2, right? So now if I print tuple1, this is the same thing that we actually saw earlier. And now if I print the count, you can see it will be printing 2, right? And similarly, we have another bonus method called as index. And in that scenario, what we can do, if I just write tuple1 dot index, and which means I want to find out the index of a certain element. If I write only C, so what will happen here? So the first time the compiler will encounter C, it will just print out the index of that item. Which means if I have two items, two C's, so obviously the compiler will only print the index of the first C, not the second C. Okay. So in this scenario, it will print 0, 1, and 2, right? So it will print 2. So if I write tup1 dot index of C, it should print what? 2. Okay. So I hope I'm clear till this. Okay. So I will give you 10-15 seconds to just ponder upon whatever we have seen till now. And if you have any problems, you can ask. Okay. So just 10 to 15 minutes. Just think upon it and let me know. Okay. So I guess we can move ahead with the next topic. Okay. Uh, so before moving on with the next topic, let us go to the most important question, that why do we use tuples and why do we use when do we use lists? So again, we have seen that there are various similarities in the case of list as well as tuples, right? List is also used to store data, right? So a sequence of data, and tuple is also used to store a sequence of data. And again, uh, if you just go to the pointers, it will be much more clearer. So you can see that they are both used to store what collections of data. They are both heterogeneous in nature, right? So what is heterogeneous in nature? Which means in a list we can store more than one data type at the same time. Similarly, in the case of tuples also, we have seen that we can store multiple data types at the same time, right? The third thing was what? And they are both ordered, right? Which means the order in which we are actually storing the data in a list as well as a tuple. That order is maintained by the compiler. The compiler does not change the order, right? The fourth thing is they are both sequential, right? So they are both sequential data types. So you can iterate over the items that are contained in both the list as well as the tuple. So we have seen that, right? And also items of both types can be accessed via integer index operator, right? Provided in a square bracket called as index. So again, we have seen this as well in the examples. Okay. Now let us come to the differences. So these are the most important. So the first difference is that tuples are actually immutable in nature and the lists are actually mutable. Now, what is immutable and what is mutable? Let us understand. So if you remember, we have said that tuples are actually immutable, which means the values cannot change. We cannot change the values of a tuple, right? But again, in the case of lists, we have seen that the lists are actually what? Mutable in nature, right? So we have seen that whenever we want to change, by default, we tuples do not allow us to change the values. But again, if I want to change the values, what we did was we actually converted the tuple into a list. Then we changed the values in the list, and then after changing the values in the list, what we did was we actually converted the list back into a tuple, right? So that was the only way by which we can actually change, add, or modify elements of a tuple, right? So again, we can understand that by default tuples are immutable, which means we cannot change the values. But again, if I convert them into lists, we can change the values. So again, in that sense, it means that lists are actually mutable, which means the values of a list can be changed. So this is the first difference. Okay. The second difference is tuples are actually more memory efficient than lists. Okay. Now let us see a demo of this, and it will be much more clearer to you that if I create a tuple and if I create a list with the same data types and same number of elements, let us see that which variable, uh, either the tuple or the list, takes the more amount of space in the memory. So let us see that. Okay. So let us go to the command prompt. And what we will do here is we will define a list called as L1, and we will have 8 elements, for example. So 1, 2, 3, 4, 5, 6, 7, and 8. right? And suppose we have a tuple called as L2, and again we will have 8 elements. So 1, 2, 3, 4, 5, 6, 7, and 8, right? Now we will import something called as sys. So we will import sys, okay? And with this sys, what we can do is we can write sys dot get size of. So get size of is a method of the module called as sys. So get size of, okay? And we will just in the parameter, we will just pass the name of the variable. So L1 is the list. So let us get the size of the list. If I write L1, if I press enter, you can say that it is taking 120, suppose, bits of storage in the memory, right? Again, if I write L2, this is for the tuple, okay? If I press enter, you can see it is taking 104 bits in the memory. So again, we can see that using the same elements, same data types, a tuple is actually taking lesser memory than that of a list. Okay, so that's the first. That's the second difference that we were actually talking about. Tuples are actually more memory efficient than lists. Okay, what's the third thing? Third thing is it is saying that when it comes to time efficiency, again tuples have a slight advantage over lists, especially when lookup to a value is considered. Now, what is this lookup to a value? It means that whenever we are searching for a value in a list, that searching in the case of a tuple will take less time, but that searching in the case of a list will take more time, right? Now, again, to demonstrate that, what we can do, suppose, let us say that let us import something called as time. Okay, so time it is a module through which we can actually check out the execution time of a program. Okay, so using this time it, what we can do is, suppose let us write something called as a statement. Okay, and what is this statement? Statement will be that we are actually creating a list. Okay, so let us create a list L, and we will have 8 elements. So 1, 2, 3, 4, 5, 6, and 7 and 8, like this. This is the statement. And what we will do is we will write time it dot time it. Okay, and we will write the statement. Okay, if I press enter, you can see that for creating this list with 8 elements of type integer, we are actually taking about 0.72 or 72 nanoseconds. Okay, but if I just change this statement to a tuple, so which means we are, instead of a list, we are creating a tuple. Okay, and we press enter, and again we print the time. Okay, so if I press enter, you can see it is taking actually lesser time than what time the creation of a list took. Okay, so again we can see that whenever we are working with tuples, tuples are actually very time efficient compared to a list. Okay, okay, this thing can again be done using another way. Let us find that way. So let us just exit this. Okay, so we can write here that Python minus m means if I want to just run a script, right? Run a module as a script. So we can use this method. Okay. So if I write Python minus n, and if I write time it, right? And how do we write the script? So we will use double quotes or single quotes, inverted quotes, right? And what we can write here, we can write L is equal to so that this is the statement that actually we are writing. So L is equal to 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, right? If I press enter, you can see it will give us the time. So it took about 64 nanoseconds, right? So if I do the same thing, but instead of a list, we give a tuple. Let us see what happens. So you can see it is taking 11 nanoseconds compared to 64 nanoseconds for a list. Okay. So again, we can see that working with a tuple is actually time efficient compared to what a list, right? Now, if this is clear, then what we can do is we can move into the next topic called as Python sets. Okay. Now, if you remember in the previous class, we had told you that in the case of list, in the case of dictionaries, in the case of tuples, we have always said that lists are also ordered, dictionaries are ordered, and tuples are actually also ordered, right? So if every data uh, type in Python is ordered, So why do we need to always say that that it is ordered, right? So why do we need to say it? Because whenever I told you in the previous class as well that whenever we will study sets, we will see that a set is actually an unordered data type. Okay. So again, Python sets are actually what are used to store multiple items in a single variable. Likewise, in the case of list, likewise in the case of dictionaries, as in the case with the tuples. Okay. So all the data types are actually used to store what multiple items in a single variable. But what's the difference? The difference is that a set is a collection which is both unordered, unindexed, as well as it allows for what it does not allow for duplicates. Okay, so these are the three important things that we need to remember. What is unordered? If you remember the definition of ordered, we have said that the order in which we are actually giving elements into a list or a dictionary or a tuple, that order will be actually maintained by the compiler, right? But in the case of sets, what happens is whatever order we give elements into a set, that order will not be maintained by the compiler, right? That's the first thing. The second thing is if the order is not maintained, obviously we cannot use the indexes, right? So if there is no order, which means every time three can become one can become two, or two can become zero. If that is the case, then obviously we cannot use the concept of indexing. So obviously it is unindexed, right? And also, whenever we have a set, so we have seen in the case of tuples, we have seen in the case of lists as well as dictionaries that they allow for duplicates, right? Lists allows for duplicates by default. Tuples allows for duplicates by default. Dictionary will not allow for duplicate keys, but they will allow for duplicate values, right? But a set will not allow any duplicates, right? So that is the third thing that we need to keep in mind. Okay. So again, whenever we actually define sets, we are defining sets with the use of curly brackets. So don't confuse this with dictionaries because dictionaries also use curly brackets. Sets also use curly brackets, but the main difference is what? And in the case of dictionary, it is actually the elements are actually in the form of what key value pairs, right? But in the case of tuples, they will be just normal elements. They will not be in the form of key value pairs. But again, both of them use curly brackets. So don't get confused between a dictionary and a set. Okay. Now, so again, let us go to the demo. And what we can do, we can invoke Python, right? And what we can do is we can write this set. This is the name of a variable. And what we can write, we can give curly brackets and we can define three elements. So we can write apple, we can write banana, and suppose we can write shape. Okay. So if I print this, if I print this set, you can see, oh, sorry, if I print this set, you can see that this is the set. Also, universal function length we can use to calculate the length. So if I print len of this set, again it will be equal to 3, right? And also another universal function is type. If I print type of this set, again you will be able to see that it belongs to a class called as sets. Okay. Now, so again, you can see that whenever we are having sets, likewise in the case, as was in the case with tuples also, as well as in the case, as was the case with lists as well. So we can see that a set can be of type strings. So every variable here is actually strings, right? It can be of type integers. So every variable here are actually integers. And also it can be of a type what? Boolean. So you can see true, false, and false. So these are actually Boolean values. Okay. Also, at the same time, a set can have what strings, for example, it can have integers, it can have Boolean values, integers, strings. Okay. So again, we can say that it is of a heterogeneous nature, right? So it can allow for different data types to exist together at the same instance of a type, right? Okay. Again, if I print the type, we have discussed this. If I print the type, it will print the type as belonging to the class of set, right? And also we can use the set constructor like this. So as we have seen with the lists, list constructor is there, dictionary constructor is there, tuple constructor is there. So again, in the case of set as well, we can have the set constructor to make a set. Okay. So let us see a demo of this, and here we will be able to understand everything. Okay. So if I just go to this demo, again, here also you can see that we are actually using what double brackets, right? As was the case with tuples, there also we use double brackets. In the case of sets as well, whenever we are using the constructor, we are actually using double brackets. Okay, so I have specifically written that note the double round brackets. Okay, so let us look at the demo. So if I write this set, and if I use the constructor, so I can write set, and I will give double brackets. Okay, and inside this brackets, what I can write? I can write apple, I can write banana, right? And I can write what? Chip. Okay. Now if I press enter, so you can see the order in which I have given the data. So which means first I have given apple, then I've given banana, then I've given chip. Okay. So if I press enter, and if I just print this set, let us see what happens. So again, you can see that the second element came to the first element came to the second, the third element is as it is. So that is not an issue. So again, but you can see that the order in which we have actually given the elements, that order is actually not maintained by the compiler. Okay, so that's the reason why we say that a list is a set is unordered and it is unindexed. Why unindexed? Because if every time the index of the variables, index of the elements change, so we won't be able to use the concept of indexing. Okay. Okay. So let us move forward. So again, you cannot access the items in a set by referring to an index number or a key. So we have discussed this why. But you can loop through the set items using a for loop. Okay. Or ask if a specific value is present in a set by using the in keyword. Okay. So again, very quickly, if I look at this demos, if you remember that we had this set. Okay. And what I can do is I can write for I in this set, right? And I can give 4 spaces. I can write print of I. So what will happen that every item will be printed in new lines. So if I press enter, you can see that every item is printed in new lines. Also, we can use the in keyword. So again, if you remember the usage of the in keyword, if I write if, for example, apple in this set, if this is true, then what we can do? We can write print yes, right? Else, what we can do? We can write print no. I can print no. Okay. So if I just press enter, it will print yes because Apple is actually present in this set, right? So again, we can use the in keyword as well with the sets, okay? But we cannot use the indexes. That's it. That's the only difference, right? Now, uh, again, to add one item to the set, we use the add method. So again, let us see the demo. So if I have this set, so let's print that first. So this set has 3 elements. So what we can do, we can write this item, this set dot add, and suppose let us add some other element called as orange. Okay, and now if I print this set, again you can see that orange is actually came to the second position. It should have been at the last position, but again the order is not maintained in the case of a set. So again we can see that. Okay. Also, what we can do is we can use the update method. So what's the update method? You can understand. So if I have this set, so this set will now have 4 elements, right? And suppose we have a set 2 with the 3 items. So 1, 2, and 3, for example. Okay. So what I can do is I can write set. Uh, I can write set. I can write this set. Okay. So I can write this set dot update, and I can write set 2. Okay. If I write this, and now if I print this set, so you can see that all the elements of set 2 has also been added to what? The actual set. Okay. But again, you can see that the items are unordered, they are unindexed, right? They're actually stored in the sets haphazardly, in haphazard manner. Okay. Now, So just okay. So we'll come to that point later. Okay. Now what we can do is also with the update method, what we can do is we can. So in the previous example, we have seen that we are actually updating elements of one set to another set, right? But again, using this update method, we can also update not only a set, but we can update actually what any iterable object. So it can be either a tuple, it can be either a list or a dictionary. So which means if I print this set like this, sorry, so you can see that we have these items, right? Suppose we have a list called as a comma b comma c, b comma c. These are strings, so inverted commas like this. Okay, and what we can do, we can write this set dot update, and we can write L. So which means now we are trying to update a list into a set. Okay, so if I press enter, and now again if I print this set, so again you can see that A, B, and C, these things have also been added to the set, right? So it doesn't matter that I will always use a set to update. You can also use other iterables like tuple, a list, or a dictionary in that set. Okay. Now, to again remove an item from a list, we can use the remove method or the discard method. Okay. So both of them do the same thing. Let us see how it works. So again, if I just write this set dot remove, okay, dot remove, and suppose let us I want to remove the variable the element 3. Okay. So if I write a presenter, and again if I print this set, you can see that this 3 is actually removed from the set. Okay. Also, the discard method also does the same thing. Okay. So if I just instead of remove, if I write discard, okay, in this case, let us discard 2. Okay. And if I press enter, again, if I print this set, you can see that 2 is actually deleted from the set itself. So again, a remove method and the discard method does the same. Okay, one and the same thing, but again, there are two methods, so we need to remember that also. Also, there is another method called as pop. Okay. Now, what is pop? Pop is actually whenever we use pop, what happens is actually we delete the last element from the set. Okay. So, which means if I print this set, mm, so you can see that A is the last item, right? But let us see if I use pop, which element is actually popped out, right? By definition, it should pop out the last element, right? So if I write this set dot pop, okay, by definition it should pop A because that is the last item. But let us see what it pops. If I press enter, you can see this pop 1, right? So again you can see it is unordered, right? So the thing that was actually at last, that was A whenever we printed the set. But again, whenever we are actually popping the element, the compiler decided to place elements in a opposite manner, and in that scenario, it saw that 1 is the last item and it popped out 1. Okay, so we can see various examples by which we can actually understand that a set is a unordered set of items. Okay. Okay. Now there are two methods, more methods. One is the clear. So clear means actually we are actually if we want to clear the items of the set, so we can use the clear method. And again, if I want to delete the set altogether, I will use the del keyword. Okay. So if I just write this set dot clear, if I write this, and now if I print this set, you can see that it will be an empty set. You can see this is the empty set. Okay. And also if I write del of this set, and if I press enter, and now if I print this set, we will actually get an error. Why? Because this set is actually not there in the memory anymore. Okay, so that's the reason why we will get an error. Okay, now again you can loop through the set items by using a for loop, right? So I will not go to the demo of this because this is very much clear to all of us. We have seen demos of this kind earlier as well. So again, if we have a set like this, apple, banana, and cherry, if I just write for x in this data set, if you print x, so obviously every item of the set will be printed in new names. But I guess we have seen this example earlier as well. So I guess this is there by mistake. Okay, anyways. Okay, so very important so 4 methods we will see now. Okay, and these are actually what the first one is actually union. Okay, just see the difference between update and union. So whenever in the second example, this example, we can see that if I have a set called as ABC, 3 items, and we have a set 2 with 3 items, 1, 2, and 3. If I just write set 1 dot update of set 2, right? So what happens is the elements of set 2 get updated into set 1, right? Which means a new set is not created. Okay, a new set is not created, but what happens is the elements of set 2 is just gets updated into the set 1. Okay, a new set is not created. So whenever we use the update method, just remember a new set is not created. Okay, but whenever we use the union method, what happens is a new set is created. Okay, and how do we see this demo? Let's understand. So if I have set 1 is equal to, for example, a comma b comma c, right? And suppose we have set 2 is equal to 1 comma 2 comma 3. Okay, if I write set 1 dot update of set 2, if I press enter, just see what is coming. If I press enter, nothing will come. We are just returning back to the prompt. Okay, which means a new set is not created. If a new set was being created, that set would have been printed in that prompt. Okay, so which means if I just go to set 1, you can see that everything has been updated into set 1. Okay, but if I do not use the update method, I use the union method. Let us understand what happens. So again, let us say that set 1 is ABC, set 2 is 1, 2, 3, and instead of update, I do what? Union. Okay, so if I do union and if I press enter, if a new set will be created, so that set will be printed now. Okay, if a new set was not created, set would not have been printed. So that is what we have seen in the previous example. A new set was not created, so the set was not printed. But in this case, if I press enter, you can see that a new set is being created and the new set is actually printed. Okay, so which means also what we can do, we can write set 3 as well. So whatever set is being created now, we can save it in another set. Okay, so what we can write, set 3 is equal to what? Set 1 dot union of set 2. We can write that as well. Okay, and now if I print set 3, you can see that the same thing is happening, right? So again, very important, whenever we have the update method, a new set is not created, or whenever we do not have the update method, a new set is created. Okay, why am I repeating this? Because that will help us in the next two slides. Now, if I go to the next slide, we can see two methods. One is a intersection update and one is about intersection. So again, as I discussed in the previous slide, whenever we have the update method, a new set will not be created. And if I do not have this update method, a new set will be created. Okay. Now let us understand what does actually intersection method do. So the intersection update method will keep only the items that are present in both the sets. Okay, so we can see that one set is there is one set called as X. We have 3 elements: Apple, banana, and cherry. Right. We have another set called as Y. We have 3 items: Google, Microsoft, and Apple. So again, we can see that Apple is actually common in both the sets. Okay. So what will happen is it will only keep the items that are present in both the sets that are common to both the sets. Okay. Let us see. So suppose we have X equal to apple, banana, and cherry, and cherry like this. And suppose Y is equal to Google, Microsoft, and Apple like this. Okay. Now, if I just write X dot intersection underscore update, so obviously whenever we have update, a new set will not be created. So again, if I press enter, a new set will not be printed, right? So if I write x dot intersection update of y, new set is not printed. But if I print x, you can see that only Apple is there. Okay. But again, if I just write the update, if I don't write the update, let us see what happens. So again, let us say x is this, y is this. And instead of update, we will just remove the update. And if I press enter, if a new set is created, it will be printed. Okay. So if I press enter, again you can see a new set was created, and that's the reason why it is printed. Okay. So again, if there is update, new set is not created. If there is no update, a new set is created. Okay. Now, so we've seen the intersection methods. Then we have the difference methods. Okay. Symmetric difference. Again, we have the two things: update and no update. Right. So what does symmetric difference update do? This method will actually keep only the items that are not present in both the sets. So again, we can see that that is actually not common, right? So you can see that in X and Y, Apple is common. So instead of Apple, it will actually uh, it will actually keep the banana cherry and Google and Microsoft. Okay, so let us see whether the same thing happens or not. So X is Apple, banana cherry, Y is Google, Microsoft, Apple, and instead of intersection, what do we write? We write symmetric difference, right? And let us write update, which means a new item will not be created, new set. So if I press enter, it has been updated into X. If I print X, you can see that apart from Apple, everything is there. Okay. And also, if I again initialize the sets, okay. And if I do not write the update one, so you can see that after I press enter, a new set will be printed. So again, the same thing is printed. Okay. But just we do not have the apples because apple is actually common between both the sets. So in this symmetric difference method, what will it do? The things that are not common will be printed. In the case of intersection method, the things that are common will be printed. Okay. Now, so we will understand that why do we need sets? Okay. So again, we understood why we need lists. We understood why we need dictionaries. We understood why we need tuples, and also we need to understand why do we need sets. Okay, so the Python sets are actually highly useful to efficiently remove duplicate values from a collection like a list. Okay, so we will see this. This is the main thing or the main concept why we actually use sets. Okay, so we have studied everything about sets, but again, whenever we use sets in a daily life, this is the main thing why we use sets in a daily programming lives. Okay. Okay. The second thing is what the Python sets are actually highly useful when we want to perform common math operations like unions and intersections, and we have seen that how we can do that. Okay. In the case of lists, in the case of tuples, in the case of dictionaries, we cannot perform unions and intersections, but again, in the case of sets, we can do that. Okay. Okay. So let us move to the first point. So if I go to the command prompt, and suppose I have a list called as L, and we have 1, 2, 3, 1, 1. Okay. Suppose 4, 5, 7, 7, 8, 9, 9, and 3, for example. So you can see that we have what happened. Okay, we have given 2 commas. So we can see that in this list we have various elements that are actually duplicates. Okay. So again, how do we use a list? So suppose we want to create another list where we only want to have the unique values. Okay. So let us say that this list is called as L1. Okay. And we can use the list constructor. So if I can write list, I can give brackets. Okay. And what I can write set of what? L. So again, we are using the set constructor as well as the list constructor. So what will the set constructor do? Since it does not allow duplicates, so always obviously it will just pick up the unique values, right? And what will this list constructor do? So after the set has picked up the unique values, the list constructor will actually convert it into a list, and that list will be saved in what? L1. Okay. So if I just press enter and if I press L1, you can see that actually it is printing all the unique values. Okay. Am I clear till this? Yes, no? Anyone?
Yes, sir.
Yes.
Yes, sir.
Okay. Okay. So it's 7:20, 7:21 actually. I will not start with the new topic because I won't be able to complete it. So in the next class, we will start with file handling. Okay. And then we will go to the exception handling. And lastly, we will have something called a string format. Okay. So that is the thing that we will do in the next class. So for this class, we have completed tuples as well as we have completed Python sets. Okay. So let me stop the sharing first. Uh, and after stopping this, in the chat box, what I will do is I will give the attendance link. And also, I've seen that only 64 students have joined the Google Classroom. So just join the Google Classroom, everyone. I'm requesting everyone because everything that is related to this class is actually posted in this Google Classroom. Okay. So just a second. Okay. So I have given the Google Classroom code as well. Okay. So again, if you don't have any problems regarding today's class, you can leave the meeting and you can go and give the attendance. If you have problems, you can stay back and you can ask me the questions. Okay. Thank you. That will be all for today.
Thank you, sir.
Yeah. Thank you. Thank you.
Excuse me, sir.
Hmm.
If
Tell
I
me.
if I install a module, okay, then
Hmm.
write some code and give that code to someone, okay, and that person doesn't install that module. Is it
Actually, your voice is not clear, audio clear. Actually, can you write in the chat box? Okay. Suppose if I install a module in my system and write my code, then give that code to other who have not installed this module. Is it going to work? See. The thing is, what's the module? Acha, are you talking about the custom modules? Just unmute yourself and tell me.
yes, sir.
Yes. So again, if you have a custom module, so suppose in the previous class we have seen the example that if I write, for example, mod.py, right? And in that module file we have suppose a dictionary and a function, right? So if I just take that module and give it to someone, right? That someone, if he just keeps that module in the same folder in which his program is, okay, then he can run my module. Yes, definitely.
Okay, sir. So that means she or he doesn't need to install that module.
No. If he or she has Python installed, that's it. That is enough.
Sir,
Okay.
and one more thing, are we going to learn about hooks concept in this class? Yes,
Oops. Yes, in the next class or the last class, because whenever we want to teach oops, the concept of oops are very simple. So it will take only one class. And again, whenever you will actually do programs using oops, then if you face problems, you can always contact me. So again, in the next class or by the last class, I guess, we will cover oops. Yes, definitely. We will cover the concepts of classes, objects, methods, inheritance. We will cover those concepts.
thank you, sir.
Okay. Yep. Okay, what about the rest? If you do not have any issues with today's class, you can leave the meeting and you can give the attendance. And if you have problems, you can stay back and ask me the questions. Okay, because we need to end the meeting so that we can have the recording saved.